Lesson 23, student page 129. All right, you guys, this is going to be your favorite lesson. That's because this one's all mechanical. There's no graphing weirdo-ness that we have to figure out. And this one's all about how do we solve using elimination. And that means we have to look at our two equations. We have 2x plus y equals 6 and x minus 3y equals negative 11. And think about how to easily get rid of one or the other, eliminate one of the variables. So we're either going to get rid of x, which would mean multiplying the bottom by negative 2, but I always try to avoid multiplying by a negative if I can find a positive. And if I was going to multiply the top by 3, and let's just look and see what would happen if I multiply this top by 3. If I multiply this top by 3, look how nice that is. If I multiply by 3, I'll get 6x plus 3y equals 18. And that plus and minus makes everything go away. So you'll notice I've multiplied by 3 all the way through. I got 6x plus 3y equals 18. I'm going to draw a line, and I'm going to add each of the items. 6x plus x, 7x. I have this fabulous zero pair, it's gone, equals 7. And that means when I divide through by 7 on both sides, let me get that 7 out of the way. 7 and 7. Now I've got those ones that I love. Love zeros, love ones. Keep that in mind. X equals 1. We have an answer. X is 1 in this case. So now the next thing we have to do is substitute back in what would happen if we put 1 into the first system. So I've written 2 times x, which we're going to let be 1, equals plus y equals 6. That means 2 plus y is 6. When I subtract 2 from both sides, 2 minus 2 plus y equals 6 minus 2, we get y equals 4. Now, we've done a great job, but we do have to check and make sure that our answers are fabulous. And we're going to do that by putting our x value of 1 in here and our 4 value here. So what we have originally was x minus 3 times y equals negative 11. Let's make sure it works. So we're going to go ahead and put in the 1 for the x, 1, and the 4 for the y, and we get 1 minus 12 equals negative 11. And we love this. Negative 11 is negative 11. I hope you like this part of the lesson. Exercise 1 asks us to explain a way to create a new system of equations with the same solution as the original that eliminates the variable y from one equation. That means that we have to focus on how we're going to get rid of y. And what we see here is y's are already opposite in sign. Whenever I see opposite in sign, I feel really happy because I know I don't have to do a lot. And honestly, if I could just multiply this equation by 3, that would take care of everything. So strategy is going to be to multiply the second equation by a positive 3. When I do this, I'm going to eliminate the y's in both equations. This is a good strategy. Let's see what it looks like. All right, at this point, I've copied over the first equation, 2x plus 3y equals 7. I've distributed the 3 to the x, the y, and the 1, and I'm ready to go. So what I see is I've got a zero pair here, which makes me very happy, and my leftovers are 2x plus 3x, 5x equals 10. That means x equals 2. 5 times 2 is 10, or divide both sides by 2, I'm going to get x equals 2. It's a very nice feeling. So I'm going to go back in and I'm going to say, all right, what does y equal? 2 times what we figured out is x is 2, plus 3y equals 7. That means 4 plus 3y equals 7. You subtract 4 from both sides. That's the same as adding a negative 4 to both sides. There we go. And we get 3y equals 3. Y then must be 1. We like that. Now, since we solved for this answer in the first equation, we're going to double check in the second equation. So our double check, make sure we have the right answer, is x minus y equals 1. X is 2, y is 1, and indeed 1 equals 1. 2 minus 1 is 1. We're very happy. For problem 2, they ask us to explain a way to create a new system with the same solution as the original that eliminates the variable x. Well, now we have a bigger problem because the 2x and the x are the same sign. That's going to require us to multiply by -2. All right, in this case, eliminating x from both equations requires a change of sign. In other words, we had positive 2x and positive x. We've got to make them negative in order to get the opposites that we need for a zero pair. Let's see how that looks. So we know the first equation is going to stay the same. We're not trying to change it. I've got to multiply -2 times everything, times x, times -y, and times 1. -2x plus 2y equals -2. And then we're going to add it up just as we have been. Woohoo, we got a zero pair. We like that. So we have 5y equals 5. That's good. We're going to divide both sides by by 5, excuse me. And y equals 1. Look, another lovely one. Zeros and ones everywhere. Good answer. Now we need to make sure that, well, way to annihilate your answer there. Let's see if we can fix this. So we're happy. Y equals 1. Woohoo. Now we have to find out what x equals. So let's go ahead and see what we can learn. We know that 2 times x plus 3 times what we know is y, which is 1, equals 7. That means 2x plus 3 equals 7. If I subtract 3 from both sides, that means I'm adding a -3 to both sides. It doesn't matter where I do it. We get, there's our zero pair, see it? And it surrounds a 2x. 2x equals 4. That means x equals 2. I hope you all see that. We have our answers. Y is 1 and x is 2. Let's see if that works. Put 2 in the bottom equation. That's how we do our double check. Check in the other equation. You never want to go back to the first one, because if you made a mistake, you're going to make the same mistake. And in the first equation, it says x, which is 2, minus y, which is 1, equals 1. And indeed, 1 equals 1. We got it. Yay. We have an answer. 2, 1. Yay.